Our planet holds remarkable secrets. Hidden beneath the surface lie spectacular formations. These are the karst landscapes. They inspire awe and wonder in all who encounter them. Imagine a world sculpted over millennia. Karst landscapes are more than just beautiful scenery. They are home to unique flora and fauna. Join us now as we venture into the fascinating world of karst landscapes. The story of karst begins with a simple element, water. Rainwater, slightly acidic, seeps into the ground. It encounters soluble rocks like limestone. Over time, a remarkable transformation occurs. The water carves out intricate networks of caves. As the process continues, the ground above can become unstable. This leads to the formation of sinkholes. Above ground, we see rolling hills and disappearing streams. Below, a hidden world of caves and underground rivers awaits. Our journey into the heart of karst landscapes begins with limestone. This sedimentary rock plays a pivotal role in this geological drama. Limestone's story starts millions of years ago. Tiny marine organisms like corals and shellfish thrived in ancient seas. Their remains, rich in calcium carbonate, accumulated on the seafloor. Over eons, these remains were compressed into layers. This slow, steady process is called sedimentation. Over time, these layers hardened, marking the birth of limestone. This limestone is the very foundation of karst landscapes. The formation of limestone is a testament to geological processes. Ancient seabeds were buried under layers of sediment. The immense pressure compacted and solidified the calcium carbonate remains. This process, known as lithification, transformed loose sediment into solid rock. Geological forces eventually thrust these limestone formations into the open air. Thus, the stage was set for the creation of karst landscapes. Geological time operates on a vast scale. Continents drifted, oceans rose and fell, and mountain ranges were born. Tectonic forces lifted ancient seabeds, forming cliffs and plateaus. Erosion sculpted the limestone into dramatic formations. Rivers carved valleys, exploiting weaknesses in the rock. The true magic of karst unfolds beneath the surface, where water plays the starring role. The key to karst's beauty lies in the solubility of limestone. Rainwater, slightly acidic, infiltrates the ground and encounters limestone bedrock. The carbonic acid dissolves the calcium carbonate, carving out networks of fissures and cracks. These cracks widen into channels and tunnels. The result is a hidden world of subterranean rivers and vast chambers. This underground realm, shaped by water, is what we call karst. The allure of karst landscapes extends far beneath the surface into caves. These subterranean labyrinths offer a glimpse into the hidden forces shaping our planet. Mildly acidic rainwater dissolves the limestone bedrock, creating vast underground chambers. This continuous cycle of dissolution and erosion gives birth to awe-inspiring caves. These caves reveal the relentless power of water over millennia. Stepping into a cave is like entering another world. The darkness within a cave is absolute, yet life finds a way. Bats, blind cavefish, and other invertebrates thrive in this subterranean world. Over millennia, mineral-rich water creates breathtaking speleothems. These formations are a testament to the patient work of nature. Among the most iconic features of karst caves are stalactites and stalagmites. These formations, resembling icicles of stone, hang from the ceiling or rise from the floor. As water seeps through the cave ceiling, it carries dissolved calcium carbonate. This mineral-rich water deposits calcium carbonate, forming stalactites and stalagmites. Over time, these formations can meet, creating towering columns. Each element tells a story of water, minerals, and time. Caves offer a unique window into the past. Fossils and cave paintings provide valuable insights into ancient ecosystems and human history. The study of cave formations reveals past climates and environmental conditions. Stalactites and stalagmites grow influenced by rainfall patterns and temperature fluctuations. By analyzing these formations, scientists can reconstruct past climate records. Caves serve as natural wonders and time capsules, preserving echoes of the past. Sinkholes reveal the dramatic consequences of subterranean processes on the surface. These depressions range from small hollows to enormous chasms. Acidic water carves out cavities, creating subterranean voids. Eventually, the weight of the overlying material causes the ground to collapse. The earth gives way, and a sinkhole is born. These events reveal the dynamic nature of karst terrains. The collapse of a sinkhole is a sudden and dramatic event. The aftermath can be dramatic, transforming entire landscapes. These events expose hidden cave systems and underground rivers. Sinkholes are a natural part of the karst landscape's evolution. They are part of a larger cycle of erosion and deposition. These collapses shape and reshape the Earth's surface over millennia. Sinkholes serve as valuable portals for scientific exploration. They provide insights into the underlying geology and groundwater systems. Sinkholes also serve as conduits for surface water to reach underground aquifers. They harbor unique ecosystems adapted to subterranean conditions. Studying these ecosystems offers insights into adaptation and interconnectedness. The study of sinkholes and karst landscapes is crucial for conservation. Karst terrains are vulnerable to human impacts, requiring careful management. Pollution and overpumping of groundwater pose significant threats. Sustainable land management practices are essential for protecting these environments. By respecting karst systems, we can preserve their beauty and ecological integrity. The sunlit world above may seem like the primary stage for life's grand performance, but within the depths of karst landscapes, a different drama unfolds. Caves, those hidden realms beneath our feet, harbor a surprising array of life forms, each uniquely adapted to a world without sunlight. In this subterranean world, darkness reigns supreme. The absence of light, the very foundation of photosynthesis, dictates a different set of rules for survival. Cave dwellers over countless generations have evolved remarkable adaptations, their bodies and behaviors shaped by the relentless pressure of natural selection. Consider the blind cavefish, its silvery scales shimmering faintly in the beam of a spelunker's headlamp. Its eyes, rendered useless in the perpetual darkness, have regressed, mere vestiges of a world it can no longer see. Yet it navigates its watery domain with astonishing precision, its sensitive lateral lines detecting the slightest vibrations in the water. Other creatures too have embraced the darkness. Cave crickets, their antennae longer than their bodies, feel their way through the caverns, their sensitive appendages detecting prey and avoiding obstacles. Blind cave spiders, their silk webs a lifeline in the abyss, patiently await the arrival of unsuspecting insects, drawn to the faint scent of guano deposited by cave-dwelling bats. The influence of karst landscapes on biodiversity extends far beyond the confines of caves. The unique topography of these regions, characterized by sinkholes, disappearing streams, and isolated hills, creates a mosaic of habitats, each harboring its own specialized community of plants and animals. Sinkholes, those dramatic depressions in the Earth's surface, often serve as natural traps for water, creating isolated ponds and wetlands. These aquatic oases, shielded from the surrounding landscape, provide refuge for amphibians, reptiles, and aquatic invertebrates, many of which are found nowhere else on Earth. The porous nature of karst terrain also influences plant life. Water drains quickly through the limestone bedrock, creating a challenging environment for many plant species. As a result, karst regions often support a unique assemblage of drought-tolerant plants, their roots adapted to seeking moisture in the thin soils and rocky crevices. The isolation of karst hills and plateaus, separated by valleys and sinkholes, further enhances biodiversity. These islands of habitat often harbor relict populations of plants and animals, remnants of past climates or once widespread species now confined to these fragmented landscapes. The dance of dependence intertwined ecosystems. Karst ecosystems, both above and below ground, are intricately connected, their fates intertwined in a delicate dance of dependence. The flow of water, the lifeblood of these systems, links the surface world to the hidden realms beneath our feet, transporting nutrients, shaping habitats, and influencing the distribution of life. Organic matter, such as leaves and twigs, falls into sinkholes and disappearing streams, carried by the water into the cave systems below. This detritus, broken down by bacteria and fungi, forms the base of the food chain in the cave environment, supporting a diverse community of invertebrates. Bats, those iconic denizens of the dark, play a crucial role in this ecological web. Emerging from their caves at night, they forage for insects, pollinating plants and dispersing seeds across the karst landscape. Their guano, rich in nutrients, falls to the cave floor, fertilizing the soil and supporting a unique community of decomposers. The health of karst ecosystems hinges on this delicate balance. Disruptions to one part of the system, such as pollution of surface waters or destruction of bat roosting sites, can have cascading effects throughout the entire karst landscape, impacting both surface and subsurface biodiversity. Fragile footing conservation challenges in karst regions. Karst landscapes, for all their beauty and ecological significance, are fragile environments, highly susceptible to human impacts. The very features that make them unique, their porous bedrock, interconnected caves, and specialized ecosystems, also make them vulnerable to pollution, habitat destruction, and climate change. Pollution poses a significant threat to karst systems. Because water flows rapidly through sinkholes and into underground aquifers, contaminants introduced at the surface, such as agricultural runoff, sewage, and industrial waste, can quickly spread and contaminate vast areas, impacting drinking water supplies and delicate cave ecosystems. Urbanization and infrastructure development, with their associated impervious surfaces, alter natural drainage patterns, increasing runoff and erosion and exacerbating sinkhole formation. Construction activities can also damage or destroy caves, disrupting bat roosting sites and impacting the fragile ecosystems within. Climate change adds another layer of complexity to karst conservation efforts. Changes in rainfall patterns, increased frequency of droughts, and rising temperatures can all impact karst systems, altering water availability, shifting plant communities, and stressing vulnerable species. Protecting these unique and valuable landscapes requires a multifaceted approach, encompassing sustainable land management practices, pollution prevention, responsible recreation, and climate change mitigation. By understanding the interconnectedness of karst ecosystems and the threats they face, we can work to ensure their preservation for generations to come. Unlocking nature's secrets. Karst as a scientific laboratory. Karst landscapes are living laboratories, revealing Earth's history, climate clues, and groundwater systems. Geologists study these formations to understand Earth's surface processes. Hydrogeologists explore water flow and quality in these unique systems. Biologists find rich research opportunities in cave ecosystems. Karst regions offer insights into geology, hydrology, and biodiversity. Section 2. Drip by Drip Deciphering Climate History in Karst Formations. Within the depths of caves, hidden from the vagaries of surface weather, lie silent witnesses to Earth's climatic past. Stalactites and stalagmites. These intricate formations, built drop by drop over millennia, are not merely geological curiosities. They are time capsules, preserving a detailed record of past rainfall patterns, temperature fluctuations, and atmospheric conditions. Each layer of a stalactite or stalagmite, like the rings of a tree, represents a period of growth, its thickness and chemical composition reflecting the environmental conditions prevalent during its formation. Periods of abundant rainfall result in thicker layers as more water seeps through the cave ceiling, carrying dissolved minerals. Droughts, conversely, are marked by thinner layers or even growth hiatuses. Scientists, using sophisticated analytical techniques, can extract tiny samples from these formations, their delicate instruments probing back through time. By analyzing the ratios of different isotopes, variants of elements with different numbers of neutrons, researchers can reconstruct past temperatures, rainfall patterns, and even atmospheric carbon dioxide levels. These paleoclimate records, gleaned from the depths of karst caves, provide valuable insights into the natural variability of Earth's climate system. They help scientists understand how our planet has responded to past climate changes, providing a baseline against which to compare current warming trends and predict future climate scenarios. Life on the edge, studying evolution in action. The isolated and often extreme environments of caves, with their perpetual darkness, limited food resources, and unique ecological pressures, have driven the evolution of some of the most extraordinary adaptations found in the natural world. Cave-dwelling organisms, separated from their surface-dwelling ancestors for millennia, have undergone remarkable transformations, their bodies and behaviors sculpted by the relentless force of natural selection. Consider the blind cavefish, its pale translucent body a stark contrast to the shimmering scales of its surface-dwelling relatives. Over countless generations living in a world devoid of light, its eyes, no longer essential for survival, have gradually regressed, their function replaced by enhanced senses of touch, taste, and vibration detection. Other cave dwellers have evolved equally remarkable adaptations. Cave crickets, their antennae extending far beyond their bodies, navigate the darkness with an acute sense of touch. Cave salamanders, their skin pale and translucent, have developed the ability to absorb oxygen directly through their skin, compensating for the low oxygen levels often found in caves. These adaptations, honed over millennia, offer scientists a unique opportunity to study evolution in action. By comparing cave-dwelling organisms to their surface-dwelling relatives, researchers can unravel the genetic mechanisms underlying these adaptations, gaining insights into the processes that drive biodiversity and the remarkable plasticity of life on Earth. The future of karst, balancing conservation and discovery. Karst landscapes are treasures worthy of our utmost care and protection. These fragile environments face threats from pollution, habitat destruction, and climate change. Balancing scientific exploration with conservation is crucial. Responsible karst conservation requires a multifaceted approach. Protecting water quality is paramount. Limiting pollution is essential. Sustainable land management minimizes erosion and preserves karst landscapes. Promote responsible forestry, urban planning, and livestock management. Educating the public about karst conservation is essential. Promote responsible caving and tourism practices. Embrace a holistic approach to karst conservation for future generations. A hidden world revealed. Our journey into karst landscapes reveals dynamic systems, sculpted by water over eons. We've marveled at subterranean cathedrals and delicate stalactites. These landscapes shape unique habitats, supporting specialized communities. Yet they are fragile, vulnerable to pollution and climate change. Responsible stewardship is essential for their preservation. Guardians of a fragile legacy. We are guardians of a fragile legacy, shaped by ancient forces and entrusted to our care. Preserving these landscapes requires understanding their vulnerabilities and committing to sustainable practices. Protecting water quality is paramount. Contaminants can quickly spread, impacting drinking water and ecosystems. Limiting pollution requires collaboration among all stakeholders. Responsible land management is essential. This includes promoting responsible forestry and urban planning. Educating the public is key. Fostering appreciation and responsible tourism empowers stewardship. Research and monitoring are crucial for effective conservation. Studying groundwater flow and monitoring changes provide valuable data. The future of karst landscapes lies in our hands. By embracing a holistic approach, we can ensure these natural wonders inspire and provide essential services for generations. Let us be worthy guardians preserving karst landscapes for future generations.